Okay, class, today we're doing section 8.3, which is analyze geometric sequences and series. So the first definition is in a geometric series or a sequence. And remember, a series is just when you sum up the sequence, so it had the same pattern. So in a geometric sequence, the ratio of two consecutive terms is constant, and the constant ratio is called the common ratio, and it's denoted as an R. And in arithmetic sequences, we used the letter D for common difference. In geometric, it's an R for common ratio. So here we're going to determine if this is geometric, so we need to see if there is a common ratio. So we always take the next term over the previous. So 16 over negative 32 is minus 1/2. And we have minus 8 over 16, which is minus 1/2. And 4 over minus 8 is minus 1/2. So we do have a constant ratio or a common ratio R of minus 1/2. So we have rules for a geometric sequence, and the rule for a geometric sequence is a sub n is a1, the first term, times r to the n minus 1. And specifically, just the r has the exponent. So you need to remember order of operations. Okay, so that's something you do need to memorize. So here we're going to write a rule. So for example 1, in the previous slide, we found that our r was minus 1/2. My first term is a1, which is minus 32. Since it's geometric, we're going to use the geometric rule, which is a sub n is a1 times r to the n minus 1. So my nth term rule is my first term, which is negative 32, times r, which is minus 1/2 to the n minus 1. And that is the nth term rule. Okay, then we need to find a8. So here we're going to plug in n equals 8. So a sub 8 is negative 32 times negative 1/2 to the 8 minus 1, which is 7. So we just plug this number into our calculator, and we can find the answer. Okay, and here I really want you to follow along with your calculator to make sure you're doing your orders of operation correctly. So when you plug it in, you should get A8 is 1/4 or 0.25 on your calculator. So please follow along to make sure you get that same answer. Okay, so here we're going to write summation notation to write the sum. So we have 2 plus 8 plus 32, blah, 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 all the way out to 32,768. So in order to do this problem, we have to see what the pattern is. So what we can do is we can hope that this pattern is geometric. Okay, because remember we're going to use our sigma notation. We're going to start with n equals something or I equals something. We're going to have the pattern rule up to whatever number. So we're going to see if we have a common ratio, because this is the geometric. Okay, so 8 over 2 is 4. 32 over 8 is 4. 128, if we divide that by 32, we get 4. So my r is 4, my a1 is 2, so we know that it's geometric, and the geometric rule is a sub 1, or a sub n, is a1, or 2, times your r to the n minus 1. So we always put the rule here. So it's 2 times 4 to the n minus 1. So we plug in n equals what to get out? Well, if we plug in n equals 1, 1 minus 1 is 0. 4 to the 0 is 1, times 2 gives me 2. So I plug in 1. What number do we have to plug in to get this? My best suggestion is take a lucky guess and try it. So let's try what happens if we plug in, say, 7 for n. So then we would have 4 to the 6th power and multiply that by 2. So if we plug in 7, you get 8,192. So let's try plugging in n equals 8 to see if we get that number. So this would be 4 to the 7th and multiply that number by 2. And that works. So we go all the way up to 8. Okay? because when we plug in 8 into here, we get that last number out. And that is using summation notation to write the rule. Okay, let's go ahead on to the next problem. So here it says the sum of a finite geometric series is this formula. So if you know the series is geometric, then we can use this to find the sum. So we're going to find the sum of the first 10 terms, so n equals 10. And we're going to confirm that this is geometric. 2 over 4 is 1 half. 1 over 2 is 1 half. 1 half over 1 is 1 half. So we do have our r is 1 half. My a1 is 4. Okay, so in my formula, S10, the sum of the first 10 terms, is 4. My a1 is 4 times 1 minus r to the n. My r was 1 half to the 10th power, all over 1 minus 1 half. Okay, so I have 4 times 1 half to the 10 over 1 minus 1 half, which is 4 times. Well, what's 1 half to the 10th? You can find out what that number is on your calculator. 2 to the 10th on your calculator is 1024. So this is 1 minus 1 over 1024 over 1 minus 1 half is 1 half. Okay, so I can just simplify this on your calculator, and you should follow along as well. Pause it as needed. And when you plug it into your calculator, you should get 7.99 approximately. That's 10. It's approximately equal to 7.99. Right? But when you plug it in and you get S10 exactly, it's 1023 over 128. Okay, and you should be able to do this without a calculator, just by finding common fractions, multiply by reciprocal, multiply by 4. Okay, so that is how we use that formula. So we can move on to the next. And we have the formula for the sum of an infinite geometric series. So this is if it goes on to infinity. Okay, so again, another formula. So in order to use this formula, you have to know that it's geometric. So if you expand this out, you can confirm that it's geometric. If you plug in 1, you get 16 times 1 half, or 8. When you plug in 2, you get 16 times 1/4, which is 4. When you plug in 3, you get 16 times 1/8, which is 2. And the common ratio is 1 half. See, this is the common ratio, and that's your A1. So it is geometric, okay? So the sum, but just S. We don't write S10 or S infinity, just write the S to indicate that it is the infinite, is the first term. And when we plugged in n equals 1, we got 8 out. So our first term is 8. And then we're going to divide it by 1 minus our r, which we found to be 1 half, which is 8 over 1 half. We're going to multiply by the reciprocal and get 16. Okay, so what this means is the sum of this infinite list of numbers is 16. Right? We plugged in 1, we got 8 and 4. We keep multiplying it by 1 half, and we get this long list of numbers. 1/4, 1/8, 1/16, plus dot, 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 all the way out to infinity. We add up all of those numbers, we get 16. That's pretty remarkable that we get this nice whole number when we sum up an infinite list of numbers. Pretty darn amazing. And when you think of it further, 8 plus 4 is 12, plus 2 more. So 8 plus 4 is 12, plus 2 more is 14, plus 1 more is 15. So if I sum up all that list of all those fractions all the way out to infinity, it equals 1. Pretty cool. Okay, well that is all I have for tonight. So that is section 8.3 on analyzing geometric sequences and series. I hope you have a wonderful evening.